Unlocking the universe, Newton's laws of motion. Planets in orbit, galaxies swirling, all governed by Newton's laws of motion. Get ready to unlock the secrets of the cosmos with these fundamental principles.
First law, inertia. The universe's couch potato. Picture this, you're floating in space, no gravity, no friction, just you and a baseball. It's a surreal experience, isn't it? What happens when you let go? It just floats there. That's inertia in action. The baseball doesn't move unless you push it, and it won't stop unless something stops it. Objects in motion stay in motion. Objects at rest stay at rest. This is true whether you're in space or on Earth. On Earth, friction tries to slow things down, but inertia is always at play. Imagine driving a car. When you hit the brakes, friction helps stop the car. But inertia is what makes you feel like you're being pushed forward. Why wear a seatbelt? Because if your car stops suddenly, you'll keep moving forward. Thanks, inertia. The seatbelt is there to counteract that forward motion and keep you safe. Inertia is why you feel a jolt when the bus starts moving, or why it's harder to push a full shopping cart. The more mass something has, the more inertia it has, and the harder it is to change its state of motion. If something's moving, it keeps moving. If it's still, it stays still. This principle is universal, applying to everything from cars to planets. Unless, of course, you apply a force. Whether it's a gentle push or a powerful kick, force is what changes the motion of objects, overcoming inertia. Second law, force, mass, acceleration, the cosmic equation. Newton's second law is a fundamental principle that governs the motion of objects in our universe. Objects keep doing what they're doing unless a force acts on them. This is the essence of inertia, a concept introduced by Newton's first law. But what happens when a force does come into play? That's Newton's second law. It tells us how the velocity of an object changes when it is subjected to an external force. Remember that baseball in space? Push it, and it accelerates in the direction you pushed. The relationship between force and motion becomes evident here. The harder you push, the faster it accelerates. This demonstrates that acceleration is directly proportional to the force applied. Now, push a bowling ball with the same force. It won't accelerate as quickly because it has more mass. This shows that acceleration is inversely proportional to the mass of the object. Newton's second law, F equals ma. This simple yet profound equation encapsulates the relationship between force, mass, and acceleration. Force equals mass times acceleration. This equation is a cornerstone in the study of physics and engineering. It's the key to understanding rockets, cars, and planetary orbits. Rockets launch into space by expelling gas at high speed. Cars accelerate on tracks due to engine force. And planets orbit stars due to gravitational forces. The Earth is pulled towards the Sun by gravity but doesn't fall into it because of its mass. The balance of gravitational force and the Earth's inertia keeps it in orbit. Instead, it orbits the Sun. This delicate balance is a perfect example of Newton's second law in action on a cosmic scale. Newton's laws describe the very fabric of our universe. They help us understand not just the motion of everyday objects, but also the grand movements of celestial bodies. From the smallest particles to the largest galaxies, Newton's second law is at work, shaping the cosmos. Chapter 3, third law, action and reaction, the universe's dance partners. For every action, there is an equal and opposite reaction. This fundamental principle, known as Newton's third law of motion, is a cornerstone of physics. It explains how forces work in pairs, always interacting with each other. Think about jumping on a trampoline. You push down, and it pushes back, launching you into the air. The harder you push, the higher you go. This is a perfect example of action and reaction in everyday life. Firing a rifle? The bullet shoots out, and the rifle recoils backward with equal force. The explosion propels the bullet forward, while the rifle moves back, demonstrating the same principle. Rockets work the same way. Expelling gas pushes the rocket upward. The force of the gas being expelled downward creates an equal and opposite force that lifts the rocket into space. Every force has an equal partner pushing back in the opposite direction. In a tug of war, each team pulls with equal force, creating a balance until one side overpowers the other. This dance of action and reaction keeps the universe in constant motion. From the smallest particles to the largest celestial bodies, everything is engaged in this cosmic dance, maintaining the delicate balance of our universe. And there you have it, a quick overview of Newton's three laws of motion. These laws are the foundation of classical mechanics and essential for understanding the physical world. Thanks for watching, and don't forget to like and subscribe. Remember Sir Isaac Newton, who unlocked some of the universe's greatest secrets.